right. Good afternoon, everybody. Thanks for finding your way down here to the dungeon to learn about CoreDNS. My name is John Belamaric. I'm one of the maintainers of CoreDNS, and as well as Kubernetes. Here to talk about specifically the extension points in CoreDNS for developers. So this is the deep dive. I'm not going to go over what CoreDNS is other than very, very briefly, but really going to jump into actual things you can do to customize it and make it work how you want. I do have another session tomorrow on CoreDNS that's more around configuring it for sort of advanced use cases as opposed to modifying it and building it. But so if you're interested in that sort of thing, please come to that as well. So we have essentially three ways that you can customize DNS that people would customize CoreDNS that people would typically do. The first one is rebuilding it with external plugins, and another is to use it as a library to build your own DNS server or executable of some sort. And finally, it's building your own plugin, which allows you to do all sorts of fun stuff. So I will talk about all three of those today. And so let's get started. Did it advance? No? All right. All right, we'll start with the easiest one. Actually, in fact, it's called, the subtitle is Extensions Points for Developers, but this one you actually don't need to be a developer to do. You don't need to go. You don't need anything except Docker and a shell. So what this is sort of getting at is that CoreDNS, this is one of those things I'll talk briefly about what it is. It's a DNS server, but it's architected in such a way that every request that it picks up goes through a chain of plugins. And each plugin has the option to either service that request and provide a response, or to modify the request and pass it on to the next plugin in the chain, or to simply do nothing with it and just pass it on to the next plugin. And then when a plugin does actually do something with a request, it gets passed back down, the response essentially gets passed back down that chain. It's just a call stack of functions. And so you can actually manipulate the response on the way back out if you want. So that plugin system makes it really easy to add in your custom behaviors. There's a bunch of third-party plugins available. When I say it's an external plugin, what that really means is that it's not built into CoreDNS, the one you'd pull down off of GitHub or the one you'd pull down off of Docker Hub. Instead, it's one you have to build in yourself. It also means that we, as the core maintainers of CoreDNS, aren't really going to give you a lot of help with it if it doesn't work. You're going to have to go talk to whoever built it. One, I guess, thing I didn't call out, it's on the slide, is that you'll hear I say you have to build it. The reason for that is that CoreDNS is completely statically compiled. There's no dynamic loading. It's written in Go, and certainly when we wrote it, there wasn't. You didn't do that in Go. You couldn't. You can now in newer versions of Go, but we still don't do it. Instead, we control it with a simple file that you modify and rebuild. The other thing, well, I'll call it out in a minute, but let's see. So let's actually do this now. So hopefully our network connectivity is good enough that it works, but these are the three simple steps you need to do to include a new plugin. First, clone it from GitHub. Second, modify plugin CFG. Third, build it, and then you're done. So first step, cloning it. So it looks like kind of a nasty Docker command here, but what we're doing is not actually that bad. This is just using the Golang Docker image so that you don't have to install a Go development environment on your workstation. It's running that. Let's see, does the pointer show up? Probably not. The -u statement essentially is just saying, when we clone this, normally this Docker container is going to run as root. We don't want all the stuff that gets cloned onto our file system here to be owned by root, because then we can't modify plugin CFG without sudo. So it's just a convenience. So we cloned it into a directory, and we cd into that directory, and we check out a particular branch. I just do that in slides, really, and you'd want to do it if you want your builds to be repeatable. But you know, all of the dependencies tend to progress, and if you don't check out a particular branch, you run into all kinds of annoying problems. All right, let's give this a try. The setup here is a little weird. I need to move this. Let's see. I'm going to have to come down there, so I think, so I can see what's going on. Move this over. Did it get stuck? Can you? Let me look down there. I have a shell here open. But I can't see the screen from up there. So I will come down here and join you. All right. This is the... There we go. All right. So I will paste in that command, except that I didn't copy it properly. All right. So that might take a minute, so we'll talk a little bit while it... Yeah, that's kind of slow. We'll talk a little bit while it does that. And you get to see my notes. So, let's see. All right. So, this is what the plugin CFG is. While it's cloning, hopefully we'll see the plugin in CFG in just a moment. Actually, the one I want to hit. All right. It's a really simple file. It's just the directive and the Go module. So in the core file, that is the file that you use to configure CoreDNS, you'll see a bunch of configuration directives. That's actually just what comes right out of here. And then the Go module normally is, basically if we don't see a bunch of slashes in there, we're going to assume it's in the root CoreDNS repository. But if we see a bunch of slashes, then we're gonna pull it from wherever. So in this case, we're gonna pull the firewall plugin. The firewall plugin is really cool, and you can see it in my notes. I will talk about that a little bit tomorrow when I have a little more time. All right, so here we can see. So firewall plugin basically will allow you to do sort of advanced blocking of queries. And so it fits in this plugin chain along with the ACL. So the plugin CFG actually defines the order that the request will be processed in. Just like the plugins are all built in at compile time, actually the ordering of processing is built in at compile time, which kind of sucks, but it's how it is right now. And we haven't had a good enough reason to change it, because it's not that hard to rebuild if you've got some really crazy requirements. So I want firewall to live in roughly the same place, because it does roughly the same thing. All right, cool. So that's it. We edited that. And then we want to build it. To build it, I'm also going to use Docker. And the reason is because I don't want to have to install Go on this machine. Actually, I have Go 111 on this machine, but it doesn't work with Go 111 at this point. All right, that is going to build. The next thing I'm going to show you after we do the pulling in an external plugin is the way to sort of build your own special purpose executable. And one of the reasons you want to do that is so that you don't have to deal with all of this. So here we're pulling in all kinds of stuff. a lot of this stuff comes in from all the plugins that are already part of CoreDNS. So for example, the Kubernetes plugin pulls in a bunch of libraries to do authentication against all the different things that kubeconfig, you can authenticate. So it's got stuff from AWS and from Azure and from Google Cloud and all of that. So there's tons of dependencies that get pulled into an ordinary CoreDNS. If you don't want all those dependencies and you want a small executable, then you can do this a little bit differently. And you can even just strip out all those plugins from your plugin CFG too. That's another way. All right. Let's see if I can talk more while we wait for it to build. One of the things about this, since we're using Docker to do this actual build, even though I'm building this on this Mac, I'm running in a Linux container in Docker, the build. So the executable that I get out of this, it's going to be dropped in my local file system, but it's going to be a Linux executable and I won't be able to run it. So when we go to run it, I will also use a Docker command. And what I will run is a very simple, actually I can show this. It's a very simple command that's just going to spit out the list of plugins that are used, that are installed in CoreDNS. So whenever you come across a strange binary, and you choose to run it for whatever reason, you could do dash plugins and see if the plugin you're looking for is actually installed. Unfortunately, it orders them alphabetically, not in the order of the plugin CFG. So another thing that would be really nice to fix. All right, hopefully our build's almost done. You see all the Kubernetes stuff's getting compiled. Let's see. This was the command we used to build it. It's just a simple make. From a make file, you could actually also use go build, but when you modify the plugin CFG, the make file will also do a go generate, which will actually change a bunch of imports and stuff. So you want to do that. And then, all right, that's next. Oh my goodness. All right, it's not that exciting, so why don't we move on so I don't run out of, oh, except that it's done. All right. Yeah, so then we can run it. So yay, we listed all the plugins, one of which is our firewall plugin, which is now included. All right. So the reason it says DNS.firewall is because CoreDNS internally, if this doesn't collapse on me, CoreDNS internally is built using a product called Caddy, which is a Go-based web server originally, but really is just a server framework at this point. And so you could actually use it to build any kind of server, and we used it to build a DNS server. All right, I should have moved this window over to where I can see it before I got back up here. All right, so that is including an external plugin. The next thing is what I mentioned. Oh my goodness, this is painful. All right, sorry about this, folks. All right, present. And I need my notes, sorry. The next thing is the building that main executable, or replacing the main.go. And that's done, for example, by if you've heard of the Kubernetes node local DNS service. So that's actually based on CoreDNS. It runs, it builds a special CoreDNS that includes only a few plugins. It includes like the forward plugin, which is what we use to talk to the upstream CoreDNS, or upstream from node local, and cache, of course, and then things to manage CoreDNS like health checks and readiness checks and things like that, metrics. But the reason it does it this way is that, one, it makes it much smaller. So we basically get down to about as small as you can get for a Go runtime, which is like 10 megs in RSS. There's a bunch of stuff that just comes with Go that makes it a little bit bigger. And since it's going to be on every single node, we want it to be as small as possible. The other reason is that this way it can actually hook into the startup code and it can do something different. And what it does in particular is it does some fancy tricks to steal the VIP so that the DNS traffic goes to the local instance of it instead of to the upstream. And it also, in particular, a really nice thing it does is turn off connection tracking for those UDP calls, which prevents a lot of issues and avoids some bugs in certain versions of the Linux kernel. So that's a really cool project if you run Kubernetes, which most of you probably do here. To check out is the node local DNS, which is a beta feature at this point. Okay, so another example of this is something I call DNS cached. This is actually just written in order to teach this stuff. It's not actually like something, I mean, I guess you could use it. There's no reason not to, but its source code is in this repository here. And it's a very simple DNS caching server. Users of it wouldn't even know that CoreDNS is behind it. Basically, it just runs on your local node and presumably and answers queries, sending them upstream as it needs to, and they can run it and don't have to worry about how to write a core file, which is our configuration file, to make it do what you want. Because you're sort of taking over the main function, you can change the command line flags to do whatever you want. I can show you what that looks like. I do this awkward dance again, but hopefully not as bad. I'm not going to build this one though, so I'll save you from that. So in here, it's actually pretty simple. There's some, like I said, we use Caddy as this sort of framework. So there's some initialization stuff you need to do in order to get the Caddy to behave exactly how we want. And then there's a very simple main function. This is all it does. It parses the flags that come in, so that creates this structure that just captures the configuration. And the way I did this one is then that object that captures that configuration will generate a core file, which in turn gets fed into the Caddy start routines. So when we pull in the individual plugins that we're interested in, they also pull in what we call our DNS.server, our internal DNS server function or class, and that in turn is sort of registered at the init function for that registers us with the Caddy framework. So that's how Caddy knows to start up a DNS server and not to start up an HTTP server, because it's sort of through the init module init routines in that DNS server function. So finally, after we start that, we just wait forever, basically. How much time do I have left? I can probably click in to the DNS cached itself, if it's interesting. So this is what actually does the logic. Here's how we decide in this particular instance which plugins we want to include. So we just do these anonymous imports, and that pulls in, these are the only plugins built into this particular executable when it runs. So then we parse flags, and finally those flags, the struct that results from that, are just used to actually drain a core file that just like you would do for an ordinary CoreDNS instance, which ends up instantiating all of those things. All right, so that is that's number 2. For number 3, let's go back here. Number 3 is writing your own plugin. So writing your own plugin is actually super easy. You basically write 4 functions. We'll talk about those in a second. But one of the things that as a sort of community we want to do with CoreDNS, one of the goals of it is simplicity. And part of simplicity, it's sort of like we try and live by the Unix philosophy a little bit of like, do one thing, do it well, at least especially for our plugins. So while we tend to categorize plugins into 3 different categories, I tend to think of them as these backends. Backends are ones that will pull data from some source. So Kubernetes pulls data from the Kubernetes API. File pulls data from a zone file, etc. Those do that function. Another category are what I call mutators. So these are things that operate on the request. They take the request and they do something with it. They rewrite it. They append something like NSID to it. Or maybe they block it, an ACL. Or configurators, kind of a weird word, a made-up word maybe. But those modify the internal state. What IP address do I bind to? Should I log this? I guess, log I would think of as that too. Health, ready. So those don't do anything to the request per se, but and they don't provide a source of data, but they change the way CoreDNS behaves. So if you're going to write a plugin that you want to share, then I would suggest that you follow that best practice. And you may want to break your plugin, may have some functionality, you may want to break it into several different plugins in order to follow that. But that said, it's a rough model. There's nothing in the code that's going to make that happen. It's just philosophy. Okay, like I said, 4 functions in order to implement a plugin. Name. The name function literally just returns the name, super simple. ServeDNS, that's the meaty one that does stuff with the request or the response. And then init and setup. Init is just what registers the directive with it registers the directive with caddy and points it to the setup function. Then as caddy's parsing, because caddy actually is what parses the core file, as it sees that directive, it's going to make a call to that setup function, whatever setup function you provided at init time. And then the setup is the thing that sort of gets you ready to go. So I have another example in that same repository, the Learning CoreDNS repository, that's an example plugin that does something maybe not all that useful, but who knows. Basically, if you've got a DNS request that goes out and returns a bunch of data, then it will actually pick one out of the many instances of a particular type of data. So in this case, it would take these 3 A records and distill them down to 1. Really just there because it's sort of a useful, didactically useful thing. All right, so the first 2 fit on a slide. Just return the name. That's used when we're logging and things like that, so we need to know the name and as we go through that. Setup.go, you've got your init function, which just registers the only one directive as a DNS directive and tells it to call the setup function. You'll notice the 2 file names. So by convention, we put all of our setup stuff in setup.go. We put the sort of main meat of the plugin in only one.go. So please follow that convention too, especially if you want it to be accepted as a primary plugin without us telling you to change it. All right, the setup.go also has the setup function, shockingly. All it does is call this parse function. So the caddy controller, in this context, it's essentially just a handle into the place in the core file where your directive appears, and it's going to hand you sort of a utility class for parsing that out. So we call this parse function. I'm not going to get into that because it's long and hairy and not useful, not relevant. But finally, after it gets back the struct that gets parsed out of there, it calls this add plugin function. So DNS server get config. It's the deep dive. I hope you're already familiar somewhat with a core file. Core file has a bunch of stanzas. A config internally in the code kind of roughly maps to directly to a stanza inside of a server block for a particular directive. It's not a one-to-one, and there's some sort of subtlety and complexity there that we can talk about afterwards if somebody's really interested. But from a thinking perspective, you can think of it as almost mapping directly to a zone. And hanging off of that config is that plugin chain. So remember that any request that comes in gets routed based upon these stanzas to a particular, or gets routed based upon its labels, com, example, etc., into one of these stanzas, and from there, that has its own defined plugin chain. So this is sort of the mechanism of how that happens is through these configs. So what we're doing here is we're grabbing the config and we're adding this plugin. When we add this plugin, actually, we're adding a func. And why in the world are we doing that? Well, the reason is that this setup happens actually during parsing time, but we don't build that plugin chain actually until the DNS server itself is spun up. And in order to build that plugin chain, we actually just go through this and call all of these add plugins, which in turn call these functions. So it's kind of like a delayed instantiation. This is important, and I call it out because some plugins, like say Metrics or the Ready plugin, they want to know about the other plugins in the chain in which they exist. And those won't actually necessarily be available at the time you do your setup. They'll be available later. And so there's a bunch of event handlers that we get out of the Caddy framework, and one of them is called onStartup. So when the actual server is starting up, it's going to send an event to each of those who've registered, to everybody who registered a callback for that event. So if you need to know about the other plugins in your chain, you need to use the onStartup callback for that. All right, lots of details. All right, so the ServeDNS. This one I cannot fit on a slide. So let's actually. I have 7 minutes. I want to leave a couple minutes for Q&A. Okay, let's talk through this one, because this is probably the more interesting one to people anyway. ServeDNS, it takes a context, it takes what we call a response writer, and it takes a DNS message. The DNS message here is the actual DNS request that was made. The response writer is essentially a struct that will let you write back to the client socket directly if you want to, sometimes. Okay, so typically these first 5 or 6 lines here, you'll see almost the same thing in every ServeDNS. You've got this sort of convenience struct called a request that we create, and for some reason we always call it state. And then you have this check. This is important. So in most plugins, the first parameter they take to their configuration is a list of zones, so that if your overall stanza, say maybe handles 5 zones, you want this particular plugin to only handle one of those 5 zones, this is where you do that check. So you won't even get here if your primary stanza doesn't take that zone, but nonetheless, if you can limit those, then this is the check, and basically, if it doesn't match the zone, it calls this next or failure. And I'll talk more about that in a second. But so assuming that we actually want to handle this request, it's something that's of interest to us, then there's the meat of the function. This particular function, as you recall, what it does is it looks at the response coming back and modifies it. Well, it's not a backend, it's a mutator. As a mutator, it has to see, and in particular a response mutator, it has to see that response before it can do anything with it. So we actually have a special kind of DNS.response writer. This is an interface. We have a special DNS.response writer called a non-writer. And what a non-writer does is when anybody calls the write function on it, it just instead stuffs it in memory and doesn't write it back to the client socket. Otherwise, you'd end up writing it twice back, which you don't want to do. So we create a non-writer, and we just call the next or failure, passing that new response writer in instead of the original one we got. We get back maybe an error, maybe not. If we get an error back, we just go along. But this essentially is calling all of those plugins in the chain. So now we've inserted ourselves in the processing. We haven't done anything yet to modify it. We've just said, hey, we're interested in the result. Go figure out what to do. And it does. We get back this response writer, this new writer, is going to contain whatever message the later plugins in the chain wrote. So then we call this trim records, which does the actual deduplication in this case, and we write it back. So you can see how we're one mutator, and we write to the response writer that we got in. Actually, it could also be a non-writer. We don't know. It depends on what the user's configured. And so we can get this sort of stack of non-writers that then gets unwound as we tweak each one along the way. All right. I'll take one more minute, and I will talk about next or failure. I only want to mention this because you're going to want to use this function. It's a utility function, and it does more. You'd think you just just call the next plugin. Who cares? But it does a little bit more than that. What it does is, in fact, what is this? So if there is no next one defined, it returns a serve fail. So that's all good. We'd want to do that anyway. So it does a little error handling from us. But more interesting is it actually handles our tracing. So one of the plugins in CoreDNS is a distributed trace plugin. And so if you actually enable that and you send a trace somewhere and you pull it up, you can actually watch a request as it goes through different plugins. And we only trace selectively. We don't trace every single request unless you configure it that way. Typically, it's terrible for performance. So if you're enabling this anything but debug, you want to do like 1 in 10,000, right? So this kind of takes care of that for you and keeps the tracing going, even if without you having to do any extra work. All right, so that is actually it for how you create a new plugin. Yay. I gotta put that back on the screen. I can find my cursor. Yes. All right. So you don't have to remember all of this. There is a how-to on the website, the CoreDNS.io website. It's not great. Probably should be updated, but it's there. That's where CoreDNS GitHub is. Recently released a book with Cricket Liu called Learning CoreDNS. All of these examples and everything, there's actually a lot more detail in the book if you're interested in this, of course, with a lot of other stuff. And Cricket works for Infoblox, and they are giving away 60 copies of the book tomorrow. So if you go there quick, he'll be there to sign them too. And if you don't get there in time, then they're giving away popcorn too. Like caramel corn and stuff, right? Good stuff. If you want, I can't be there unfortunately, but if you want me to sign it, I'm happy to do that if you track me down at the next session tomorrow at 3:20. And you can always reach us on Slack. We are actually very friendly and easy to find. So that's it. Any questions? And can I get a volunteer to run the microphone around because I don't have a track host? No? No volunteers? How about questions? Okay, you might not need to. There doesn't seem to be any questions. Any was that me? What is the relationship between CoreDNS and KubeDNS? So KubeDNS CoreDNS has replaced KubeDNS as the primary or the default in-cluster DNS server. So CoreDNS is a general purpose DNS, authoritative DNS server, and KubeDNS is only built for specifically to be used in Kubernetes. One of the issues with KubeDNS, there's a number of them, but one is that it's quite a bit more complicated. You've got like 3 different containers running in the pod. You've got DNS mask, you've got the kubeDNS itself, and you've got a sidecar for doing metrics and things like that. All of that's built into CoreDNS. There's different scaling properties for both of them, but they both, in Kubernetes, essentially serve the same function. It's just with CoreDNS, you can also customize your core file to do all kinds of other things if you want to. Yes, sir.
So to make sure I understood, with the, I think the DNS cache example that you had,
Yeah.
Is that a way to show how we could get around the need to build or recompile compile by actually having a server that doesn't those anonymous imports?
So that's an example of how you can, if you had a very specific set of requirements that you wanted from a DNS server, and you did not want the people using that or the systems that that's going to be on to be able to do anything about other than what you exposed through these command line flags, either because you don't want the complexity of having to support them or whatever it is, right? It lets you sort of not have to do much work and actually build a fairly functional DNS server.
Quick follow-up.
Yeah.
Are you looking for implementations of non-buildable, pluggable plugins and approaches, or is that on the feature roadmap, or you already looking at it?
Are you asking, are we looking for people who have built those things?
Or are you looking to add that in as opposed to having the static, only buildable plugin?
Oh, dynamic plugins?
Yeah.
So there's two things I would like to do, but it's not necessarily a priority, and also add complexity. One is dynamic loading of plugins, sure. The other is dynamic ordering of plugins. And so there's no reason technically why we can't order them however you put, however you want. It's just backwards compatibility, first of all. The most natural way to do that would be take them in the order they're listed in the stanza. But that's going to screw everybody backwards with backwards compatibility. Another way would be to separately list out the order, which is awkward. So we sort of haven't had a real need, and so and there's issues with it, so we haven't really pursued it. Any other questions? All right. Well, thank you for bearing with me with the awkwardness of going back and forth and finding your way down here. But have a great rest of your KubeCon and enjoy the party tonight.